Hello everyone, and welcome to our sixth week of our course on drugs and behavior. So this is our first lecture on a group of drugs. So this represents sort of a new stage in the course. So far we've talked about the history of drugs, we've talked about how drugs can affect the brain and subsequently behavior, and we've talked about drugs in society, so how drug use is viewed by society, how society tries to regulate drug use and enforce those regulations. Um, and for the next several weeks of the course, we'll start talking about individual kinds of drugs or individual drugs themselves. Uh, so that we have sort of our background knowledge in place, we have a frame of reference for how to describe drugs and for how to understand how they work and the effects they have on the individual and society at large. So this first week, we'll talk about stimulants, which are a particular class of drug. And so stimulant drugs, first we're going to define them. So what are stimulants? Then we'll talk about stimulants and the individual, both in terms of the brain and behavior. So how do stimulants have the effects they have? Now that we have our knowledge in place for how the brain works, more or less, uh, what effects do stimulants have? What do they change about the brain? And how do those changes in how the brain functions bring about changes in behavior? Now, as it turns out, we don't know the answer to all of the questions about behavior, but we understand some of how effects on the brain turn into effects on behavior. And we'll also take a look at the bigger picture. So how stimulants affect society and how society affects users and producers of stimulants. So in particular, uh, this module this week will be divided sort of into two sections. One, we're gonna spend this session looking at cocaine, which is a very particular stimulant, a single drug. Next time we will look at amphetamines and methamphetamines and related compounds. But today is really going to be just about cocaine, which is a drug we've all heard of. So we're going to learn a little bit about the history of cocaine. Cocaine actually has a long history of use because it's a naturally occurring substance. We'll look at how cocaine affects neurons, and then we'll go from there to looking at how cocaine affects the body. And again, we don't know all of the connections between effects on individual neurons and all the effects on the body and behavior, but we know many of them, and we'll talk about each. But we'll also talk about regulations regarding cocaine use. As we've already mentioned in a previous week, uh, early on there really weren't any regulations, and then regulations started coming into being, both in terms of regulating who could distribute cocaine, if anyone, and what penalties were for cocaine use. We'll also talk about some demographic information, what groups of individuals tend to use cocaine and which don't. Okay, so this lecture we'll talk about cocaine. Next lecture we'll talk about amphetamines and methamphetamines. And by the way, I'm postponing discussion of the discussion questions from last week to next lecture just to balance out the length a little bit. Everyone just turned in their first paper, so I'll be grading those and posting the grades over the next week, week and a half. And then finally, in 3 weeks, your midterm exam will be due. So that'll be an online exam. I will go into more detail about that next week. But for now, just know that it's going to cover not the week of the exam, not that week of content, but it will cover everything we've done so far. It will cover stimulants, which we'll talk about this week, and it will cover depressants and inhalants, which we'll talk about next week. So that'll be the content you need to worry about for the midterm exam. The format will be generally multiple choice, some fill in the blank, some short answers possible. So I'll talk more about that when we get to it. So the first question is, what is a stimulant? So a stimulant, broadly speaking, is a drug that enhances the excitability of the nervous system. So what does that mean? It means that it makes action potentials more likely for a neuron. So it makes them fire more easily, fire more often. And when we talk about the effects that a drug has on the nervous system, we often use the phrase mechanism of action. which just means how does a drug have the effect on the nervous system that it has. And if we want to increase the overall excitability of the nervous system, there's a number of ways we can do that. So we've already seen in our unit on the nervous system, on the brain, how complex the brain is, and especially how complex synaptic transmission is. So there's a variety of ways we can change how that system functions to bring about a certain general change in excitability. The most obvious way is to increase excitatory neurotransmission. There's a number of ways we could do that. We could make action potentials more likely, make them easier to initiate. We could change how much neurotransmitter is released from synaptic vesicles at the synapse. We could change how many synaptic vesicles bind to the presynaptic membrane. We can change how long the neurotransmitter is resident in the synaptic cleft, either by preventing it from being taken back up into the presynaptic neuron, or by inhibiting enzymes that break down a neurotransmitter. We can also, of course, have a compound that binds to the receptors on the postsynaptic membrane and makes them stay active for longer. So these are all ways to increase the effectiveness of neurotransmitters. You can also, of course, increase general excitability by inhibiting the inhibitory system, so sort of a double negative effect. So as we know, GABA is the primary neurotransmitter that inhibits excitability, that inhibits action potentials. And so if we keep GABA from being released, or if we increase how quickly GABA is taken back up into the presynaptic neuron, or how quickly it's broken down, we can in effect inhibit the inhibitor. So that's going to increase excitability as well. And we'll talk about what cocaine does, what amphetamines do in particular, as we proceed through this module. So what are the short-term effects of stimulants? So the most common is increased alertness. And as we'll see, especially for amphetamine, these attentional effects and sort of inhibiting the onset of fatigue and sleep, that was originally one of the primary benefits of the drug and one of the reasons it was developed. You also get an increase in movement, so an increase in motor activity. As we'll see, chronically, this leads to repetitive movements and stereotype movements the person exhibits. So you can sort of tell behaviorally if someone is on a stimulant by this increased level of motor activity. You also, with many stimulants, get a sense of euphoria if they're taken in sufficient quantity. So this is the so-called high, the psychological and emotional impact of taking a drug, taking a stimulant in particular. So this is what's most commonly thought to be involved in developing dependence, is trying to seek that euphoric effect, that high that the stimulant produces. So what are some stimulants? So obviously we're going to talk about cocaine and amphetamine, but nicotine in certain ways is a stimulant. In certain ways it isn't, which is why it gets its own module later on. Also because it's so commonly used that it's going to take up a little more of our attention, deserves a little more of our time in this course. Caffeine is also a stimulant. It works a little bit differently from cocaine and from amphetamines, but caffeine, of course, is completely legal. Also, its effects, its toxicity isn't quite as noticeable, so the negative effects aren't quite as extreme. So it also gets its own unit because of the frequency of use, because of difference in its legal status, and because its mechanism of action and its effects are different. But caffeine is a stimulant. But cocaine is going to take up most of our time today. And then amphetamines and methamphetamines are going to take up our next session. Okay, so what is cocaine? So cocaine is actually a naturally occurring product. It comes from a plant named Erythroxylon coca, which is often just called the coca plant. So here, in this picture, we see on the left coca leaves. On the right, we see the purified form of cocaine, this powdered form, which we've all probably seen in the media. So cocaine comes from this plant which originally grew in the Andes Mountains. As we'll see, that had an impact on its history. But it was purified in the mid-1800s. We're not exactly sure who purified it first. Here we can see its chemical structure, and it's not obvious just from the structure why cocaine has the effects that it does. Many drugs physically imitate other neurotransmitters, so we can sort of guess which neurotransmitter system they're going to have an impact on, but not so for cocaine. Nevertheless, it was purified, and as we saw last week, this purification was one of the factors that initiated drug regulation in the US. So the prevalence of drugs was a factor, but also the fact that drugs were becoming more popular. So now they were produced in purified form. It's much harder to get a toxic level of cocaine from cocaine leaves, from coca leaves, but it's much easier when you purify the drug because it doesn't take that much to produce those toxic effects. And as for its mechanism of action, cocaine is what we call a reuptake inhibitor. And this is a concept we'll come to again, especially for psychotherapeutic drugs, this reuptake inhibitor idea. So, as we already talked about in our drugs and the brain unit, uh, neurotransmitters are released into the synaptic cleft by the presynaptic neuron when an action potential comes down into the synaptic terminal. Uh, so the way cocaine works is that usually neurotransmitters are released into the cleft, and it diffuses across the cleft to the postsynaptic neuron, binds to receptors, but then it gets sort of vacuumed back up into the presynaptic neuron. And this is a process called reuptake. So there are particular proteins in the membrane that bind to the neurotransmitter and pull it back into the presynaptic neuron so that it can be reused. Of course, the longer the neurotransmitter sits out there in the cleft, the more likely it is to bind to those postsynaptic receptors, the longer it will be effective. And the more likely it is that an action potential will occur in the postsynaptic neuron. So if we shut down those proteins that vacuum neurotransmitter back up, then it's going to stay out there longer. It's going to become more effective. So we're going to have more excitability in something like a glutamate synapse, but also in neuromodulatory synapses like dopamine, like serotonin. And as we'll see, these are really the big players in the effects of cocaine on the body. So norepinephrine, serotonin, dopamine, different neurotransmitter systems, but cocaine affects them all and leaves those neurotransmitters in the cleft for longer so that the excitability of those synapses is increased. So from this diagram here, we see where these transporters are located. They're on the presynaptic neuron, and cocaine shuts them down. Temporarily, of course. That's what it does, and that's how it has its effect. Also, cocaine in sufficient quantities blocks sodium channels. So this was actually part of our discussion question from a couple weeks ago, is why drugs that are commonly developed affect synapses and not action potentials. So cocaine affects action potentials by blocking sodium channels. If you block sodium channels, sodium can't get into the neuron, and you can't get that action potential, that wave of electrical impulse that travels down the axon. And of course, once you do that, the neuron doesn't transmit at all. No action potentials. As we'll see, this has implications for effects on behavior and effects on how the body functions. But this is another effect that cocaine has, the sodium channel blocking effect, and it's going to be more global. So as soon as you block action potentials, the effect is no longer specific to certain groups of neurons, because every neuron uses sodium channels. And in fact, as we'll see, organs that aren't neurons use sodium channels also, and cocaine affects them as well. So this is going to be a very broad impact on the body. Okay, so we have cocaine. It's this naturally occurring product. As I mentioned, it was originally cultivated in the Andes Mountains. So pre-Columbian South America had a culture known as the Incas, which I'm sure we've all heard of. And the Incas cultivated cocaine. They had cocaine farms, or coca farms. And the way they would use it is not to purify it, not the powdered form or crack cocaine. It was through leaves. And so they would chew coca leaves, and it would act as a stimulant, a fairly mild stimulant, but Works as an appetite suppressant. People found they had more energy. They could work for longer without getting tired. Uh, and so that was really what coca leaves were used for in pre-Columbian America. They were used sort of the way that our society uses coffee. Uh, Jump forward thousands of years, and in the mid 1800s, we have the development of purified cocaine. And originally, this was incorporated into things like patent medicines, which we talked about last time. Again, these are products that weren't really regulated, and new laws had to be developed eventually to control what their ingredients were, what the claims were in terms of the benefits of the product. And so one of the first products that used cocaine as one of its ingredients was coca wine. So it was wine with cocaine in it. So you have this combination of the effects of alcohol and the effects of cocaine. And it was touted as a cure or a remedy for a variety of things. And its long-term consequences weren't really appreciated. And we'll see that concept recur uh, as it regards cocaine use in the 1800s. Stimulants, as it turns out, don't have withdrawal symptoms that are as obvious as something like opioids or alcohol, and so it's a little more subtle. Uh, Nevertheless, we have these patent medicines that really promoted the positive effects of cocaine, things like increased energy, um, but ignored the long-term downside. Also, one of our most popular sodas or soft drinks, Coca-Cola, originally contained cocaine, and this is not an urban legend. It actually did contain cocaine in its original formulation. It also contains the cola nut, which is why it's called Coca-Cola. Cola nut contains caffeine. Of course, no one really knows what the current formula for Coke is, for Coca-Cola, but we know that originally it did have cocaine in it. And so this was thought to be a cure for low energy and was advertised as such. It was more of a patent medicine. Now we think of it as a beverage uh, with caffeine in it and sugar, and it's obviously consumed in vast quantities, but originally it was sort of a medicine. Uh, Later on in the 1800s, it was developed as an anesthetic. It was discovered that cocaine has anesthetic properties and used particularly for work in dentistry. Um, and the way that works is it shuts down the sodium channels, as we already talked about. So it stops neurotransmission of all sorts, but used topically, it's going to stop neurotransmission of pain. So those impulses that convey pain information to the brain, it shuts those down. So that's how it works as an anesthetic. It stops action potentials from happening uh, in neurons that are located close to the surface of the skin. And in fact, cocaine is still used sometimes, particularly for ophthalmology. So for uh, surgery on eyes or treatment on eyes, cocaine is used as a topical anesthetic in the form of eye drops. And that's one of the reasons it's scheduled in Schedule 2, as we'll talk about. There are medicinal uses for cocaine. Also in the late 1800s, cocaine started being used psychiatrically. In fact, Sigmund Freud, the most famous of all psychologists, touted it as sort of a wonder drug, a miracle drug. He said it increased energy and it helped with digestion. Uh, he later became aware of the downside, the chronic effects of cocaine use, and later retracted sort of his enthusiasm for the drug. But originally, he also thought that it could be used as a way of getting people off of their dependence on opioids and morphine in particular. At the time, morphine was very popular, and so it was thought that perhaps cocaine can be used to stop that dependence on opioids. Um, as it turns out, that you're really just substituting one dependence for another. But many patent medicines that contain cocaine uh, touted themselves were advertised as being good for getting the user off opium or morphine. But it was also used for things like depression. And it does have these excitatory effects, so it does relieve some of the symptoms of depression, um, but isn't really a good long-term solution as an antidepressant. We'll get to what antidepressants are, in a later module, but early on, cocaine was thought to be a good antidepressant. And of course, cocaine began to be used recreationally as well. And cocaine was a big factor in the development of the Harrison Narcotics Act, which we talked about last week, which cracked down on cocaine and on opioids like morphine and opium. Now, there was a large racial component to this as well, and the reason it's thought that the legislation got passed was because it used fear tactics. Its proponents used fear tactics uh, to exaggerate the effects on society. If the legislation had just mentioned uh, what the drug actually does, what the rate of dependence was, it's thought that it really wouldn't have been important enough to get passed. But by creating the specter of a minority that became, in this case, it was African Americans, were described as being uncontrollable under the influence of cocaine. So it was this very strange singling out of a particular ethnic group uh, for highlighting what the downside of a drug was. It's not just that drug use was this particular drug was more prevalent in this racial group. It's also that the drug was said to have a bigger effect in this racial group. And of course, there's no science to back up any of this, but that's what was used to promote the legislation. Um, Now, this was in the early 1900s, and we'll see this idea come back in the legislation of the 1980s, that the way in which cocaine was ingested, whether it was powdered form or crack form, doesn't really have an impact on what effect the drug has, but there is a big difference in what ethnic groups use which kind. And so again, we'll see that this racial disparity, which doesn't really have a basis in scientific fact, we'll see this come up again in the 20th century. Okay, so what does cocaine do? And particularly, what does cocaine do at the behavioral level? So it has acute effects, that is short-term effects. One is anesthesia, which we already talked about. By blocking sodium channels, neurons can no longer fire action potentials. So you stop that information transmission, so you don't get pain signals to the brain anymore. Uh, there are other effects that depend on different neurotransmitter systems. So cocaine affects the norepinephrine system, the serotonin system, and the dopamine system. So when it comes to norepinephrine, norepinephrine is, of course, the neurotransmitter of the sympathetic nervous system. That is involved in fight or flight response, involved in getting the body ready for action. So it increases blood pressure, heart rate, breathing rate, it shuts down digestion. These are all things that the sympathetic nervous system does, so when you increase norepinephrine levels, you get these effects. And so by preventing a reuptake of norepinephrine, cocaine increases alertness, so that vigilance, also increases heart rate by stimulating the sympathetic nervous system. You also have effects on the serotonin system. So you get appetite suppression, and you get an increase in body temperature. And both of these are physical phenomena that serotonin is involved in. Most of the time, serotonin gets talked about with regard to mood, and that is its major function from a psychological perspective. But you also get these decreases in appetite and increases in body temperature thanks to serotonin. And then dopamine is another important neurotransmitter. And by having increased levels of dopamine, thanks to cocaine, you have a sense of euphoria, so a high. You also have increased movement, increased motor activity. As we talked about in a previous module, dopamine is involved in a part of the brain called the basal ganglia. And the basal ganglia both process reward and control movement. So by increasing dopamine levels, you create this sense of reward, this euphoria, and you also increase the likelihood of movement. So that's why people that use cocaine experience euphoria, and also why they move around more, especially these repetitive movements. In sufficient quantities, cocaine can also lead to death. by stopping the respiratory system or by stopping the heart. So you get sudden cardiac arrest. This picture here is of Lynn Bias, who was a famous case of sudden cardiac arrest through cocaine use. He was a very promising NBA player, uh, and he died because he took a large amount of cocaine. And as I mentioned earlier, the nervous system is not the only place where you find those sodium channels. They also exist in the heart. The heart needs those sodium channels in order to contract. So if you block the sodium channels, now the heart can't contract, the heart stops beating, and you get cardiac arrest. The chronic long-term effects, you have reproductive effects, and this was, the public was made aware of this phenomenon through campaigns and through awareness of a phenomenon uh, called crack babies. And these are babies of mothers that use cocaine or crack cocaine. Uh, and the thing is that there really isn't overwhelming scientific evidence that cocaine has these effects on the developing fetus. Um, Users of cocaine tend to be lower socioeconomic status, have access to fewer resources, and so have uh, lower levels of prenatal care and postnatal care. Uh, and of course, these environmental factors can also change how a child develops. And so the increased incidence of learning disabilities, it's not clear whether that's actually the direct effect of cocaine use or whether cocaine use and learning disabilities are both effects of a lower socioeconomic status. So it's not clear what happened, what is cause and effect there. It is fairly clear that cocaine does increase the incidence of miscarriage and of premature birth. So those are known effects of cocaine that can obviously affect the development of the child. Another chronic effect of cocaine use is irritability, both at a psychological level and at a perceptual level. So, for example, the sensation of insects crawling on the skin or just general increased sensitivity to pain is because of that increased neurotransmission, the increased excitability of the nervous system. And now, of course, topically, the skin will become less irritable. It can be used as an anesthetic. But if you increase the general level of excitability, you're going to have increased perception of things on the skin. You also have paranoia, so the perception of a threat from another individual, the idea that someone's out to get you. This is a chronic effect of cocaine use, and it ties into a sort of broader effect of stimulant psychosis. So psychosis is a term not to be confused with psychoticism. Psychosis means a break from reality. And so an individual with psychosis can't differentiate reality from fantasy. And paranoia and psychosis are both symptoms commonly found in schizophrenia. And it's thought that these symptoms are at least modulated or mediated by the dopamine system. And there are several reasons to think this. First, in schizophrenia, you have increased levels of dopamine, and medications that treat schizophrenia often affect the dopamine system, but not always. And so it's not clear if increased levels of dopamine cause schizophrenia or whether they're symptoms of schizophrenia. But regardless, it's thought that the dopamine system is important in these symptoms. And so cocaine obviously affects the dopamine system, and it's thought that its effect on the dopamine system is what leads to these other symptoms. Also, another point of evidence is that Parkinson's patients who have lower levels of dopamine are often medicated with drugs that increase dopamine levels. And if the dosage is too high, you'll start to see some of these symptoms appear. Paranoia and even delusions, psychosis-related symptoms. So again, evidence that dopamine is important in the appearance of these symptoms. Finally, of course, you have dependence. And dependence wasn't noticed very early on because the withdrawal symptoms aren't terribly obvious for stimulants. They're more obvious for things like alcohol and opioids. But an individual can become dependent on cocaine and on other stimulants. and this often leads them to take increasing dosages, especially if their tolerance builds up. They have to take increasing dosages of the stimulant in order to get the same euphoric effect. And this puts them at a greater risk for some of these cardiac effects, for example. So dependence with stimulants is possible. And in fact, given how reinforcing the drug is because of the euphoria, it's actually even fairly likely, relatively speaking. Not everyone becomes dependent on stimulants, just like not everyone becomes dependent on opioids or any other drug. But it's thought that the increased rate of dependence um, is because of the effects of euphoria. Okay, so who uses cocaine and how is it used? So first, route of administration. That is, how does cocaine get placed in the body? The most famous, of course, is insufflation or snorting, where the powder is inhaled. And of course, inhalants have a very fast effect on the nervous system because the substance is absorbed into the blood very quickly and gets to the brain very quickly. For a while, freebasing or smoking was also a common way of getting the drug into the body. But freebasing requires modification with chemicals that have other toxic effects. And so freebasing was popular for a while in the 80s, but isn't really that common now. Crack cocaine also was developed in the 80s, and it doesn't involve those volatile household chemicals, but it is another form of smoked cocaine. But all these things don't modify the cocaine molecule itself. Um, the powdered version is cocaine hydrochloride, but it's only the cocaine molecule that gets into the blood and gets into the brain and has its psychological effects. And of course, cocaine isn't always taken by itself. Sometimes it's combined with alcohol, and your book mentions that when taken with alcohol, the ethanol and the cocaine can actually have sort of a combined effect. They create a new chemical that has more severe effects. But later research has shown, at first it was a big concern, thinking that this is the worst combination to have because it creates this molecule that has an increased effect in terms of the downside, in terms of the toxic effects. But it was found later on that really the substance isn't found in sufficient quantities and doesn't have quite the severe effects that it was thought. However, one common combination is to combine cocaine with opioids, and in particular heroin. And this combination is often known as a speedball. And the reason these two are used in combination is that some of the negative effects of acute cocaine use, the irritability, for example, can be diminished by combining it with these opioids. But of course, combining two drugs at once makes their effects on the nervous system even more complicated. And getting the dosages right becomes very, very difficult. So, there have been several celebrity deaths attributed to this combination of cocaine and heroin, or cocaine and sometimes morphine. John Belushi, Chris Farley, both died from this speedball form of use. So again, this really increases the danger of cocaine because you're combining it with this other drug, and there are now more complex interactions that someone who isn't a doctor will find it very hard to anticipate. Cocaine is also taken with what are called adulterants. And this is a separate category because the person doesn't mean to take the adulterants. Adulterants are something introduced by distributors to cut down on the amount of pure cocaine that's required for the amount that's sold. So if you take pure cocaine and take half of it, or combine it equally with cocaine and baking soda, or cocaine and some other drug that's cheaper, you now have twice as much product, and you still get the effects of cocaine, but now you have twice as much that you can sell. So adulterants are chemicals that are introduced to cocaine to cut down on the purity of the product. But of course, again, you have a combination of drugs, and it becomes harder to predict what the effect is going to be, especially when you don't know what the adulterant is. Okay, so who uses cocaine? So now we get into the distinction between powdered and crack cocaine, and this is differentiated in the table in your textbook. And this is also broken down over history. So what we can see here is that cocaine usage in powdered form uh, is fairly evenly distributed across ethnic groups in the early 90s. Uh, and then it sort of starts to split as time goes on, but that's not important for our purposes. The most noticeable effect is for crack cocaine, and we see that crack cocaine is far more prevalent for African Americans than it is for other ethnic groups. Again, it's just another form of cocaine. It doesn't change what cocaine does. It doesn't change what the molecule looks like. So we have this racial disparity in terms of use. Who uses what form of cocaine? Uh, and there's also a huge disparity in the penalties that are assigned for each form. It takes way less crack cocaine to qualify for a certain level of sentencing than it does for powdered cocaine. Uh, and of course, this was a big issue in the 80s when this legislation was brought about uh, because of this perception that minorities were, uh, through the use of crack cocaine, were responsible for more crimes. And so the penalty became more severe. And there's not a scientific basis for assigning this different level of penalty for different forms of the same drug. As your book points out, it's sort of like penalizing edible marijuana at a different level than smoked marijuana. It's still the same psychoactive ingredient. Um, and so since then, so at first, it was 100-to-1 disparity between the amount of cocaine via crack cocaine um, and the amount of cocaine in powdered form that achieved the same level of sentence. It's been since dropped to about 18-to-1. So still is disparity, but it's progressing to a sort of a more rational level. So the idea again here is that with our drug regulations in the early 1900s, there wasn't much scientific basis for it. And then in the 70s and the 80s, these penalties, these regulations started to get a little more reasonable. But there's still some ways to go. There are still some of the regulations that are based on inaccurate social perceptions as opposed to evidence for what the drug actually does. So currently, cocaine is a Schedule II substance. If we remember from last time, the drug schedules are based on the risks and the benefits uh, of a given drug. So how likely is it the person will become dependent or abuse the drug? And what are the medical benefits of the drug? So cocaine has some medical benefits. It can be used as an anesthetic, for example. But it does have a high potential for abuse, so it's the second highest level of drug scheduling, Schedule II. So high potential for abuse, but potential medical uses, particularly as an anesthetic, puts it on Schedule II. Okay, so in the 80s, cocaine was very popular. So here we have a magazine cover, Time magazine, talking about the levels of cocaine use. It was very high during the 80s. It has since declined uh, by a factor of around 10. So it's no longer as common as it was in the 1980s. As we'll see, cocaine use is still more common than the use of other stimulants. We'll talk about that next time. Uh, Also, last time we talked about international efforts, how the DEA, the Drug Enforcement Agency, can assist other governments in trying to regulate drug production. So, for example, this has led to the destruction of coca fields in South America, particularly in Colombia, Bolivia, the main producers of cocaine. And there are also economic incentives that the government can give for growing food as opposed to growing coca leaves. But of course, these have limited effects. It's just cocaine is so profitable and fairly easy to grow that it's very hard to really cut down on the manufacture of the drugs. So we have these parallel streams of trying to control the supply of the drug, but also controlling the demand by having stiff penalties for stimulant use. And this has required a combined effort by the DEA, but also by the military, particularly looking at drug interdiction on the ocean. So drugs are often come in by boat or are flown in, and so we have a variety of components of the military that assist with cutting down on drug trafficking and drug importing into the U.S. Also, as we'll see next time, cocaine use is often cyclical with amphetamines. So as one becomes more popular, the other becomes less popular, and vice versa. And so these are both stimulants, but the public perception of a given drug can change over time. And so people that want a stimulant will often switch to the other one because they perceive the current one as being too dangerous, or because of increased regulation of that drug. And so we see this back and forth between cocaine and amphetamines or methamphetamines. And that's what we'll talk about next time. We'll look at these other stimulants. So what are amphetamines and methamphetamines? What are they used for? What are their benefits, at least in the short term? And also, what are their downsides? What are the toxic effects of these stimulants? So I will see you all in the next lecture.